Now I want to take a look at something called an in-list comparison, comparing it to a multi-valued list. So I'm going to go down to the SQL Language Reference Guide. What we're actually looking for here is the where clause. We can find the where clause by scrolling down through the syntax from the top. Here's the where clause here. Query block, where clause. Where clause again. What I'm looking for, yet again, are conditions. And here is the in condition. I didn't cover the in condition before because it's kind of specialized. I tend to think of it as a combination of equality, inequality, a list of fixed elements, a subquery list result of elements, which is generic, obviously not fixed, where you can actually check it against a fixed list of literal values, strings, dates, numbers, whatever you like. And the simplest way to do this, well, here's the syntax basically. Select something from something where an expression, whatever it is, a calculation, a subquery as well, a bunch of values, whatever you like, is in this list. So, by example, once again, it makes the best sense to explain it from a basic level by example. So first of all, back to the category table. Let's pull all the data for the category table. And here once again we have 1 to 34 rows, all the goodies, including the parent IDs null and the parent IDs not null. So now let's go and find all categories where the category ID is in this set. In other words, the category ID can be equal to 1, 2, or 10. An equivalent to this query is actually this: category where category ID equals 1, or category ID equals 2, or category ID equals 10. Now you can imagine that if you have a set with, say, 10 values in there, you get a pretty big query with a lot of stuff in it, a lot of OR clauses. So let's look at this example and verify we get 1, 2, and 10, and do this one as well. And we also get 1, 2, and 10. The benefit of using this piece of code here is that it's much shorter, much more succinct. This particular query here, I've included null in the set list. And guess what? It does find 1 and 3 parent IDs, remember, not category ID in this case. It doesn't find null because it can't match null. The only way to check null is to use the is null option, as in this case here. So in this case we're going to find parent 1, parent 3, as well as parent IDs null. You have to use is null or is not null to test for null. In this case, when you test 1 and 3 saying not in, you will find simply 2 and 4. You will not find null values because you can't test it that way. Again, the only way to check for null is using is null or is not null. As you can see, we have parent ID 4. So now let's once again pull the category data and look at some strings. So we can pull categories where name is in sports or urban, and that's what it will equate to. And using the OR compound condition, you get the same result. Once again, you can imagine if you have 10 items in here, you would have 10 separate OR compound conditions. You end up with a rather long query, and it's probably going to be a lot less efficient to use multiple OR clauses than to use just the in-list condition. And here's another example where we don't have any of this data. Why? Because sports is spelt with a capital S. We go back to the data itself and we look for sports and urban. Well, sports is up here. Sports is a capital S. It's not equal to lowercase on the first letter, and it's not equal to uppercase throughout the entire thing. And if you look for urban, you should find urban is mixed case. It's not equal to either uppercase urban or lowercase. Obviously, we could do something like this to remedy that situation, where we could say where name is in fact, no, what you have to do is you could do this. Lower or upper. So let's convert it all to lower and say this. So what it's going to do is going to go through the name column, change them all to lowercase, and then ask them if they're equal to that. Obviously, you can do the same thing here and convert it to upper. And then we have sports, and I can't type that for some reason, and urban, hit return. There is a problem with this though. If you have an index on this column, executing a function on that column will not allow you to use the index. So let's say the category table had 1,000,000 rows in it, and it's far more efficient to read just the index and then the table to check this, or just the index, because the index is smaller. Applying the lower function or the upper function to the column itself will make this query less efficient. It's better to apply it on the right hand side, which is the literal string. This is not necessarily good programming practice. However, in Oracle you can create extra indexes, and they're called function-based indexes.